Distributive property. If you have a sum or a difference that's multiplied by something, then you can break open the bracket by having the coefficient of the bracket multiply each of the things inside. If the coefficient is negative, such as, say, minus a plus b, then that's basically a negative 1 that multiplies to the positive a and positive b. That ends up being negative a minus b. Okay, so in symbols, we have a times bracket b plus c, close the bracket, is equal to ab plus ac, or left bracket b plus c, right bracket, a is equal to ba plus ca. All right, then how can we model this? Well, let's say we got b plus c, and it's multiplied by a. Well, then that's ab plus ac in area. That's how you model distributive property. And if you have, say, a plus d times b plus c, like a, d, b, and c, then you have ab, you have ac, you have db or bd, because usually the convention is to write these in alphabetical order, and cd. Subtraction can also be combined with multiplication, because remember, subtractions are adding the additive inverse, i.e. adding the sign flipped version. Now let's do some examples. Use the distributive property to write each expression as an equivalent expression. Well, this would be equal to 4 times 6 plus 4 times 3, and then evaluate the expression. Yeah, 24 plus 12 is equal to 36. When you're doing distributive property with small numbers, it is perhaps not the most brilliant idea known to man in a lot of cases, because 4 times 9 is easier to write out than this, right? But if you are just using numbers, there are still times when distributive property is useful. Like, say, 15 times 19. Well, that's equal to 15 times 20 minus 1. So 15 times 20 minus 15 times 1 equals 300 minus 15. Whoa, this is easier than going straight at the problem. So yeah, distributive property depends on the question. In this case, the question itself, wait a second. This part doesn't look like it needs a distributive property, but if you're told to use a distributive property or any other mathematical property or formula, use it for obvious reasons. Because your answer should be what you are asked. So 7 times, in brackets, 6 minus 3, that's 7 times 6 minus 7 times 3. So 42 minus 21, which is equal to 21. Alright, the distributive property can also be used with algebraic expressions containing variables. For example, this 9 times m plus 5 is equal to 9m plus 9 times 5. Which is equal to 9m plus 45. Negative 3 times n minus 5 is equal to negative 3n plus -3 times -5, or -3 and plus 15. Okay. This is basically the reverse of factoring. Like if you factor out something, you end up with something like this. Whereas before, you had, say, 4a plus 12. Okay, for our purposes right now, we should probably show how this works. So 4a plus 12. But for this one, I'm just going to go straight to, okay, 2 times 7 is 14 plus 2b. Actually, I have to write another line anyway because the convention is that the variables go in front and the constant term comes at the end. Now 5 times c minus 6, well, that's 5c minus 5 times 6, which is 30. -3d plus 11 is going to be -3d minus 3 times 11, so minus 33. Well, I mean, technically it's plus -3 times 11, but same result nonetheless. So h minus 4 multiplied by 6 is going to end up with h times 6, or 6h, minus 4 times 6. So 6h minus 24. F plus 4 times 7. Well, that's going to be 7f plus 4 times 7, which is 28. 3 times 2j plus 8. Well, what's 3 times 2j? Oh, it's 6j. Plus 3 times 8. Well, that's 24. 3x minus 5 times -4. Well, what's 3x times -4? So say, if you wanted to write it all out, feel free. It's 3x times -4, and then minus 5 times -4, as shown here. So you end up with -12x plus 20. Yeah, you just simplify. As much as you can, at least. When you're simplifying algebraic expressions, you have terms. Terms are numbers, variables, or a product of numbers and variables. Terms are connected to each other by additions and subtractions. Now, the coefficient is a numerical part of a term that also contains a variable. If it has no variable, it's a constant term, as in it's just a value. There's no variable involved. So a coefficient is what the variable is multiplied by. Like terms contain the same variables to the same powers. For example, x squared and 3x squared, these are like terms, but x is not a like term of x squared. So x and x squared are unlike terms because they have the same variables but not to the same powers. Let's identify the terms, like terms, coefficients, and constants in this expression. Well, the terms are 4m, -6m. Yeah, because the negatives are counted as part of the coefficients, we consider terms to be linked really by just additions. g, and negative 2. Now, coefficients are, in this little table of ours, 4, negative 6, 1, and the last one is a constant. Constant, negative 2. Okay, so what are the like terms? Like terms, do we have multiple constant terms? No. Do we have multiple terms that have the variable g? No. But we do have two terms that have the variable m to the first power. So, like terms are 4m and negative 6m. Alright then, let's simplify this. What does simplifying mean when you have a bunch of terms? You take all the like terms and you group them together. So that means we rearrange this and it becomes 5x minus 3x. If you want to use the commutative property of addition, it would be 5x plus negative 3x, and then plus negative 5 plus 6. Yeah, we don't want to do that much writing. So the order we add and take them off in doesn't actually matter. So that means that we can rearrange this. Commutative property of addition, basically. So that leaves us with 2x plus 1. Yeah. Let's identify the terms, like terms, coefficients, and constants here. Terms 1, 19a, 2a. Coefficients are 19 and 2. Constants are 1. And like terms, 19a, 2a. Now how about 32m plus 3m minus 14m plus 11? The terms are 32m, 3m, negative 14m, and 11. The coefficients are 32, 3, and negative 14. 11 is a constant. Okay, what about like terms? Well, we got a bunch of terms with just m. Like terms, 32m, 3m, negative 14m. Okay then, how about this algebraic expression? Oh, we got 2q and negative 8q, which are like terms. So the terms are 2q, 6a, negative 8q, and 12. The coefficients are 2, 6, negative 8, and the 12 is a constant. Like terms are, now please note that in some places the constant can count as its own coefficient, but for the most part we do distinguish the constant term as being special. Yeah, so like terms, we have two terms is q, one was a and one constant. So the two terms was just q, 2q, negative 8q. Okay then, simplify each expression. 11x plus 5x. Well, if you have 11 of something and you add 5 more of that something, you have how many of it? You have 16x. 13a plus 5a plus 2a. 5a plus 2a is 7a plus 13a is going to be equal to 20a. Now 5y plus 2 plus 5 plus 4y is going to give you 5y plus 4y is 9y plus 2 plus 5, which is 7. Now, solving equations by adding or subtracting. Well, yeah, this should probably be review for you guys because we've been doing this sort of algebra for a long time. You isolate the variable by adding or subtracting the same number from each side of the equation, and then you check your solution. Of course, you should identify the variable first because otherwise you'd be like this, doing things blindly, which is not generally considered smart. Yeah, so x is equal to, if you subtract 2 from both sides, the effect is the same as moving it to the other side and changing the sign. So 6 minus 2. So it's equal to 4. Now let's say x minus 9 is equal to negative 13, while x is equal to negative 13 plus 9. So negative 4. Because if you add 9 to both sides, well, they stay equal. Alright, exercises. Solve each equation, graph the solution of each equation on the number line. 9 plus x is equal to 10. X is equal to 10 minus 9. So, if you're reasonably practiced at algebra, your teacher is going to let you go from this straight to the solution, which is going to be x equals 1. Because, oh, you just subtracted 9 from both sides. Like, they ask you, what did you do here? I subtracted 9 from both sides. And it's like, 10 minus 9. Do you actually need to write out 10 minus 9 equals 1 at this grade level? Well, if your teacher's not completely sure you know what you're doing, probably yeah, but as you go further in experience, oh, you'll be better off. So if you graph it, normally it's usually a dot, but my equipment is not very good with dots, so a cross mark it is. X marks the spot. And no, that doesn't mean that if y equals something, I'm going to use y marks the spot. I'm still going to use just a crosshatch. So, y plus 2 equals negative 1. Y equals, if you like, it's negative 1 minus 2. Otherwise, just negative 3 will cut it. In my experience, at least. Okay, then. X minus 6 is equal to negative 4. X is equal to, yeah, by North American convention, you should probably show this intermediate step, but x equals 2. So you move the negative 6 over and change the sign. Or you can say you added 6 to both sides. It doesn't matter. You end up with the same result. Right, that's not as on the 2 as I'd like. There we go. Okay. If your teacher prefers, you might want to label this, like say x equals 2 above your marker, just saying. There are many different ways to do these things, but the algebra part is the same. So add 22 to both sides, or just move it over and change the sign, and negative 3. So you might label y equals negative 3 on the graph, that is. Negative 9 is equal to x minus 6. Well, x is equal to negative 9 plus 6. The convention for at least your final line is going to be your variable equals some number, which means you got to flip the sides. And negative 9 plus 6 was negative 3. Oh, we got a lot of negative 3s, it looks like. Interesting. And of course, label the graph if required. 2 plus y equals 3. Well, y is equal to 3 minus 2, which is equal to 1. So, y equals 1. Solving equations by multiplying or dividing. Step 1, you identify the variable. Step 2, you isolate the variable by multiplying or dividing both sides of the equation by the same non-zero number. And then you check your solution, if indeed you're supposed to check the solution. Generally, you should, at least at this stage. But eventually, you'll get to the point where you can look at the solution and like just mentally check it, and it's like, okay. So negative 7x equals 42. That means to isolate x, we need to get 42 divided by negative 7. You can think of this as dividing both sides by the same amount, or you can think of this as dividing across. So you end up with negative, because there's one negative symbol here. Nothing cancels. So 42 over 7 is 6. So x is equal to negative 6. Now, a quick mental test would give us, okay, negative times negative cancels. 6 times 7 equals 42. Done. There. That would have checked the problem. Solve y over 2 equals negative 2. You can think of this as times 2 on both sides, or just multiplying across. So y equals negative 4. Is this reasonable? Okay, negative 4 divided by 2 equals negative 2. Done. Okay, yeah, it looks fine. If it doesn't explicitly say check, depends on convention whether you're supposed to show checking or not. Or if just going it over in your head is okay enough. So, negative 2x equals 3. X is equal to 3 over negative 2, which is equal to negative 1.5. Negative 1 equals 2y over 5. Well, negative 1 times 5 over 2 is equal to y. In this case, it's actually more practical to go, I multiplied both sides by the same amount. Why? It's because negative 1 divided by 2 over 5, you're going to end up having to show another flip. So another step has to be written out. So y is equal to negative 5 over 2. Now, 7 minus 4x equals negative 9. Therefore, negative 4x is equal to negative 9 minus 7. And that means negative 4x, yeah, let's do one thing at a time, equals negative 16. x is equal to negative 16 over negative 4, which is equal to 4. Negative 7 minus 3y equals 17. That means negative 3y is equal to 17 plus 7. So y is equal to, well, okay, negative 3y first is equal to 24. Y is equal to 24 over negative 3. So that's negative 8. And if we're going to check this, we would substitute back in and be like, negative 3 times negative 8, okay, that's plus 24. Negative 7 plus 24 is equal to, 24 minus 7 is 17. Okay, great. Now, 11 minus 5 over 7x is equal to negative 19. Negative 5 over 7x is equal to negative 19 minus 11. So negative 5 over 7x is equal to negative 30. And then you can multiply both sides by negative 7 over 5. Times negative 30. On the left side, it just cancels out entirely. And the negatives cancel each other. And this cancels with this to give us a 6. So 7 times 6 is 42. X is equal to 42. 5/7 of x, oh, that's 5 times 6. And 11 minus 30 is negative 19. You can think of it as 10 plus 1 minus 30 equals negative 20 plus 1. All right, 7 minus 1/5 y is equal to 8. That means negative 1/5 y is equal to 8 minus 7, which is equal to 1. Negative 1/5 y. And if you multiply both sides by negative 5, on this side it cancels. So y is equal to 1 times negative 5, which means negative 5. Now you may have noticed we just did a couple two-step equations. A two-step equation has two operations involved. To solve these, first you move all the terms containing your variable to one side, and you simplify that side, and then, well, you also move all the constants to the other side. And after you have the side with just a coefficient times the variable, and the other side is the constant, you divide the coefficient away. So, what do we do here? First, we isolate all the terms containing the variable c. That means c over 2 is equal to 7 plus 13. Okay then. Now, c over 2 is equal to 20. So, how do we find c? Oh, we multiply both sides by 2. So, c equals 40. Yeah. So, we isolate the variable, the terms containing the variable, and then after we finish separating the variable and constants, we divide. Okay, let's solve each of these equations. Check your solution. We don't have that much space, so I don't think we can do this typical left side equals right side check. We'll do the checking verbally, okay? So 3x plus 5 equals 9. 3x is equal to 9 minus 5, which is 4. X is equal to 4 over 3. Let's substitute this back into the original. 3 times 4 over 3 leaves us with 4. Plus 5 is 9. Okay. Yeah, it works. So 4m minus 9 equals 17. 4m is equal to 17 plus 9, which is 26. M is equal to 26 over 4, or 13 over 2. And 12 minus 0.7m is equal to 15. Negative 0.7m is equal to 3. M is equal to 3 over negative 0.7. Which is equal to negative 30 over 7. Therefore, negative 4 and 2 over 7. Okay, so what happens if we substitute this back in? Oh, negative 30 over 7, times negative 0.7. Well then, we end up with 3, positive 3. So 12 plus 3 is equal to 15. Okay, it works. Left side equals right side, QED. So yeah, if you want to actually write it out, you'd find left side equals, you substitute in on the left side, and then you evaluate and you find equals 15, left side equals right side, QED. So negative 11 equals negative 9x minus 25. We isolate the x's. We could also have done this by moving the 9x to the other side and then plus 11 on this side, but well, negative 11 plus 25 equals negative 9x, so negative 9x is equal to 25 minus 11 is 14. X is equal to 14 over negative 9, which is equal to negative 1 and 5 over 9. So, our proof, our checking, I should go over this at least a few times, would be right side equals negative 9 times negative 1 and 5 over 9 minus 25. So that comes out to positive 14 minus 25 equals negative 11 equals left side. Therefore, quadrate demonstrandum, what's been asked has been shown. Okay. 5 plus p over 2 is equal to 45. Well, p over 2 is equal to 45 minus 5, which is equal to 40. So now, p is equal to 40 times 2, or just 80. Yeah, sometimes you don't write out what's on the one side that many times in a row. Like sometimes you skip rows because that side hasn't changed. So what happens if you substitute back in? Left side is equal to 5 plus 80 over 2. So 5 plus 40 equals 45 equals right side. Therefore, what's been asked has been shown. 4 plus 22 over b equals 9. Well, you end up with, you could multiply everything by b right off the bat. I mean, that would work. Or, you can find 22 over b is equal to 9 minus 4, which is 5. And then you can multiply the b over. So 5b is equal to 22. b is therefore equal to 22 over 5, or 4 and 2/5. So, what happens if you substitute back in? You find left side equals 4 plus 22 over 4 and 2/5, which means 4 plus 22 over 5. Well then, you end up with 4 plus 5, which is equal to 9, which is your right side. And therefore, QED. Now, depending on teacher preferences, just going left side equals all the way to equals right side might not be very appreciated. Like you might need to put right side equals 9, therefore left side equals right side at some point. Just be careful. Conventions may vary. Yeah, of course, the usual disclaimer. For two-step equations, well, you can use them to represent situations where you start with some amount and you increase or decrease it at some rate. Let's say we have a laser printer. It prints 9 pages per minute, which is kind of slow, but okay. The paper tray was refilled after printing 92 pages. How many minutes will it take until there's 245 pages printed? Well, we have, let it take t more minutes. So 9 pages per minute, that's 9t, plus the 92 pages already printed equals the 245 pages that we expect to have. Okay, so 9t is equal to 245 minus 92. So 153 is what number of pages we still have to print. Okay. Now that's equal to 9t. So t is equal to 1 and then 7. 7 times 9 is 63. Okay, so it'll take 17 minutes. 17 more minutes needed. Alright then, let's solve each of these problems by writing and solving an equation. One day in late 1941, outside Moscow, the temperature dropped from negative 20 degrees Celsius over 2 hours to negative 40 degrees Celsius. How much did the temperature drop per minute? So, let temp drop x degrees Celsius per minute. Okay, that's, we start at negative 20 and then we add how much? It's 2 hours. How much is 2 hours? 2 hours is 60 minutes per hour. That's 120 minutes. So 120x. Oh, you end up with negative 40 degrees Celsius, but there is a problem here. The x value we're going to find here is negative. You don't drop negative degrees. Drop by. negative however many degrees Celsius per minute. That you can actually argue is a temperature going down. Otherwise, if the temperature drops a negative amount, that means the temperature rose, guys. Because up and down are kind of opposite directions. Just saying. Yeah, so we're looking at 120x is equal to negative 40 plus 20, because we move the negative 20 over, or we can add 20 to both sides, equals negative 20. X is equal to negative 20 over 120. So negative 1/6. So the temp change was negative 1/6 degrees Celsius per minute. In the winter of 1941, outside Moscow, the temperature ultimately reached something like negative 52 degrees Celsius. This is generally credited as saving the Eastern Front. But, well, that's somewhat debatable because logistics are kind of a thing, and they're kind of important. Okay, let's say Vladimir has $1,750 in his savings account. He has decided to deposit $122 per month until he has a total of $3,500. Okay, this guy is probably Russian. How do I know this? No. It's not the name, actually. It's the amount of money. Because Russian artillery pieces came in 100 millimeter, 120 millimeter, and 152, I believe, as their main calibers. Besides the really big or really small pieces. Whereas NATO generally came in 105, 155, and, well, okay, both sides really did field 203s, but that's beside the point. So anyway, in how many months will this occur? So, let it take M months. Well, he starts off with $1,750. And he adds $122 per month, and it equals $3,500. So 122M is equal to 3,500 minus 1,750. Well, you end up with what? 1,750. 1,750 over 122. Okay, 1,750 divided by 122 leaves us with 14 and a bit. 22 times 14. Difference from 1,750. We end up with 42 over 122 left. What can we factor out? We can factor out a 2, so 21 over 61. So it should take him this many months. This occurs in 14 and 21 over 61 months. Or 15 if he deposits lump sums once a month at the beginning or end of the month. Okay. That, of course, depends on how you count beginning and end, but we can discuss that sort of semantics some other time. Let's say we have a skydiver who jumps from an airplane at an altitude of 12,000 feet. After 45 seconds, she reaches 4,500 feet and opens her parachute. What is her average velocity during her descent before her parachute opens? For our purposes right now, we can consider velocity and speed to be the same. In practice, they are not, because her velocity is going to have a direction. The direction is downward. So, let her velocity be v feet per second, and it would be in which direction? The problem is the altitudes we have, if we take those altitudes to be positive, that means we're looking at 12,000 plus 45v is equal to 4,500. You're going to end up with a negative v. If v is negative, and you know that this is a motion where you're falling, then your velocity is going to be in feet per second up. Because going negative amount up is the same as going down. Yeah, physics is going to be fun when you guys get around to that. 4,500 minus 12,000. So negative 7,500, 45v, and v is equal to negative 7,500 over 45. That's equal to, right, it doesn't divide completely, of course. So it's going to be negative 166 and 2/3. This is in feet per second up. Now, because we have a direction, really these should all be vectors. So the velocity vector. Velocity is not like speed. Speed doesn't care about direction. It just cares about the total distance traveled. Velocity has a direction. So, the water level of a creek has risen 4 inches above its flood stage. If it continues to rise steadily at 2 inches per hour, how long will it take for the creek to be 12 inches above its flood stage? Let it take h hours. So in other words, right now we're at 4 inches above the flood stage, plus 2 times the number of hours it'll take to reach 12 inches. 2h is equal to 12 minus 4, which is 8. H is equal to 8 divided by 2, which is 4. So it takes 4 hours. Sequences and equations. A sequence is an ordered list of numbers. An arithmetic sequence is one where the difference between any two consecutive terms, called the common difference, is the same. For example, 2, 9, 16, 23, 30, the common difference is 7. Describe each of these sequences using words and symbols. In words, starting at 6, add 3 each time. Or in symbols, you can go term 1 is equal to 6, term n is equal to term n minus 1 plus 3. Or you can go term n is equal to 3n plus 3. Because your term 1 is 6, your term 2 is 9. Oh, hey, you add 3 each time. Okay, 3n. And then what do you have to do to make your term 1 true? Oh, okay, plus 3. Because term 0, so to speak, is 3 if you go back one. 8, 14, and 20, starting at, or just from 8, add 6 each time. Term 1 is equal to 8. Term n is equal to term n minus 1 plus 6. Or you can go with term n as a general formula is equal to, well, we go up by 6 each time, so it's going to be 6n. And how can we make the first term true? And by doing that, make every subsequent term also true. We add 2. All right, example 2. Find the 14th term of the following sequence. 5, 7, 9, 11. Well, we see that it's plus 2 per term from 5. Now, to get to the 14th term is going to be 5 plus 13 times 2. Why 13? Well, it's because you have your term 1. To get to term 2, you take a single plus 2. To get from term 1 to term 3 takes 2 plus 2's. And to get from term 1 to term 4 takes 3 plus 2's. So to get from term 1 to term 14 takes 13 gaps. It's like saying, oh, I have 3 rocks. How many spaces are between these 3 rocks when they're all lined up in a line? 1, 2. Like if it takes you 1 step to step over each gap, and you have 14 stopping points, you have 13 gaps to cross. Okay. You could also find the term n general formula, which would have given you this. Tn equals 2n plus 3. Okay, but going off this version, you would have ended up with 5 plus 26, which is equal to 31. Going off this version, term 14 is equal to 2 times 14 plus 3, which is 28, plus 3, which is equal to 31. Yeah, so our statement would be the 14th term is 31. Or just leave it at this, because the statement is T14 equals 31, which is the same thing as here. Exercises. Describe each sequence using words and symbols. Well, from 3 plus 1 per term. It is possible to have an arithmetic sequence where you have plus 0 per term, but, well, they just all be the same number. term n is equal to n plus, well, 2 to make the first term, and thus all subsequent terms true. 6, 7, 8, 9. From 6 plus 1 each time. And the general formula is term n is equal to n, well, 1n, but same thing, plus 5. This here is counting by 5. So from 5 to 10 to 15, okay, that's 5 each time. From 5 plus 5 each time. So the general term is going to be 5n, and oh, hey, it already works for term 1 and all subsequent terms, so we don't have to add anything. 8, 16, 24, 32, well, that's from 8. 8 plus 8 per term. The general term is 8n. And then, well, we don't need to add anything because it works already. Write an equation that describes each sequence, then find the indicated term. 5, 11, 17, 23, up to the 11th term. Okay, well, we see that it's plus 6 each time. Term n is equal to 6n. How do we make the first term true? Oh, we subtract 1. Term 11 is equal to 6 times 11 minus 1. So 66 minus 1, which is equal to 65. Yeah, we should state that this is term 11. Make it clear. Okay. 6, 10, 14, 18. Each time you go up by 4. So term n is equal to 4n plus 2 to make the first term, and thus all subsequent terms true. So term 14 is equal to 4 times 14 plus 2. 4 times 14 is 56. Plus 2 gives us 58. Eight, 11, 14, 17, and so on to the 10th term. Well, you see that it's plus 3 each time. So that means term 10 is equal to 3 times 10 plus 5. So 30 plus 5 is equal to 35. 2, 5, 8, 11, all the way to the 20th term. You have term n is equal to, oh, each time it's increased by 3. 3n minus 1. So term 20 is, the minus 1 is to make all the terms true. So term 20 is 3 times 20 minus 1. So 60 minus 1 equals 59. Term 20. Using formulas. The formula d equals rt, so distance equals rate and traveling and time. Make sure the units match up though. You don't want to match up. Oh, he drove for 45 minutes and multiply this directly by kilometers per hour. You have to use 3/4 of an hour times kilometers per hour. Otherwise, you are going to end up with something numerically very, very wrong. So distance is equal to speed times time. Or speed v. Velocity is speed with a direction, so v with a vector arrow on top. Now the formula area equals length times width relates the area of a rectangle A with the length L and width W. Let's say someone drives at 40 miles per hour for 3 hours. Well, distance is equal to, I'm used to VT, but do whatever you have to. 40 miles per hour, that's 40. And times 3 hours, 3. There are no complex units to deal with here. The units match up well enough. It's per hour versus hours, so we don't write down the units here. Or at least we don't have to. If you like, yeah, sure, 40 miles per 1 hour times 3 hours. Then you cancel the hours. Yeah, okay, that works. But you don't have to. So it's 120 miles. Find the perimeter and area of a rectangle with length 7 feet and width 2 feet. Perimeter is equal to 2 times length plus width. So 2 times 7 plus 2. 2 times 9 is 18 feet. That's a perimeter. The area is length times width. The length is 7, the width is 2. So the area is 14. Okay, let's do some exercises. How far does a train travel in 12 hours at 79 kilometers per hour? Well, distance is equal to speed times time. So the speed is 79 kilometers per hour. Like if you want to mark down the units, fine. Multiplied by 12 hours. So you can cross out these because they cancel. Per hour is basically divide by 1 hour, and 12 hours, yeah, the units cancel out. Wait, we don't need a calculator for this. Because 79 is 80 minus 1. We can use distributive property. 80 times 12 is 960. And then minus 1 times 12. So 948 kilometers. How long does it take a car traveling 60 kilometers per hour to go 250 kilometers? Well, D equals speed times time, 250 kilometers, and 60 kilometers per hour. The units are compatible, so we don't need to do conversions. The time we're going to end up with 250 over 60, which is equal to, well, first we cancel a bit, and we get 4 and 1/6 hours. What is the rate in meters per second of a cyclist? Apparently I have to specify that it's a bicycle. You can totally ride a tricycle though, or even a quadricycle. Who travels 90 kilometers in 4 hours. Rate in meters per second. Guys, we're going to need to do some conversions. So, 90 kilometers. also known as 90,000 meters, is equal to V, meters per second, multiplied by time in seconds. 4 hours is 4 times 3600. That's 1400 seconds. So this way the seconds cancel out. So we end up, the meters, we can also divide both sides by meters to get rid of that. So our V is just going to end up being unitless. It'll just be a number. So V is equal to, we can also cancel the 0. So 900 over 144. Wait a second, guys. 144 divided by 9 is 16. So, change this to a 100, and then change this to a 16, and we can still cancel further to get this down to 25, and this down to 4. So 25 over 4, we rewrite this, and it's going to be 6 1/4. Speed is 6 1/4 meters per second. The reason why we have to specify this is because we showed the units to make sure that we remember to convert them appropriately. So, and we ended up canceling the units, which left V as just a number. So we have to put a statement. If we had not shown and canceled the units, we could put meters per second right here, and that would have been it. So this cyclist, to travel 90 kilometers in 4 hours, they have to move at 6 1/4 meters per second. Which sounds pretty fast, but if you actually get on a bicycle, it's not that much. Like 10 meters a second is 36 kilometers per hour, which is like the speed that cars drive at in residential areas, at least where I live. Well, that's it for this chapter, where we went over a bit of algebra. So, see you next chapter.